have to hype myself up too. Hi. All right.
Let's start. Blockchain security is on fire.
But no worries. We're here to help you prioritize security anti-patterns by using the familiar and friendly OWASP Top 10, or 3, depending on how much time we have.
And for those of you who think that there is no value proposition to blockchain security, the industry is a $2 trillion market. It has peaked. So you know when the scammers come out, it's got to be good.
So a little bit about us. Actually, you start.
I'm Kennashka DeSilva. I am a cybersecurity consultant at a Big 4 accounting firm. I am also a Web3 ethical hacker.
Yes. I'm Amy. I'm a security engineer. And that gives me the great habit of saying security when I'm working on machine learning projects. And besides that, Kennashka and I are both in Percent 27 Hack Miami, our local DEF CON group. Thanks so much for coming.
So let's talk about some blockchain security components and basics. So we have the blockchain network. Blockchain systems are typically managed through a peer-to-peer system or network, which is used as a publicly distributed ledger. So essentially, there are public records, and then we have transactions. Transactions are represented within each block of data for the transaction, essentially. And the wallet, it allows a way to store your cryptocurrencies as a whole by ways of selling, swapping, buying, and storing your crypto overall, which uses public key encryption, typically asymmetric encryption. And smart contracts are code that are used to be executed for transaction as a whole. So how does a blockchain works? So instead of the traditional Bob and Alice, we have our gender neutral bread and alfalfa.
Give it up.
So bread wants to send money to alfalfa, and bread initiates a transaction. Bread transaction, it gets written within the blockchain. Essentially, within each different block, we have metadata of the transaction stored within each block. And then each block, it gets broadcasted to verifiers on the network, which can be ways of miners or stakers. They can help secure and verify the transaction on the blockchain. Once it goes through the verification and confirmation process, it is approved, and alfalfa receives their funds, and it gets appended to the ledger.
And now that we have some blockchain basics out of the way, I want to tell you about how we came up with a prioritization system. And actually, really, this is a story that, spoiler, the end game is that there aren't a lot of publicly available resources to quantify and qualify risk for blockchain. So we begin our adventure in the Rect database, which is based on Rect News. I don't know if you're familiar with this, but it is basically all the tea on DeFi in the dark web. So if you want to know about the latest crypto, hacks, rug pulls, and so on, this is the spot. This database is not comprehensive, but because obviously it's not just been $60 billion that have been lost in funds through the years, so much more. But the Rect database does take in audits from folks that they vet for due diligence. So I thought, okay, this is a plausible way to begin, right? You'll see that the database gives you yes, the project, yes, the chain, yes, the amount of money lost, but can we look at that type of issue column? What do you see? Exploit, 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 exploit. Does that look specific enough to you? Like, what is an exploit? It could be anything, right? So how do we narrow down so that we can map these exploits to the OWASP top 10, right? For, say, like incidence rates, as we're used to, right? With like data-driven information. We decided to go another route and to combine approaches at that point. The Immunify vulnerability severity classification system is something that Immunify, a bug bounty site, uses to qualify risk, or really like criticality, excuse me. And there's 5 ratings. And conveniently, some of these happen to be exactly the same verbiage as in the OWASP top 10, like cryptographic flaws, cryptographic failures, so on. They audit for blockchain-specific exploits and such, but they also work on like traditional Web 2.0. So obviously, there's still limitations, but what we decided to do was focus on those things that had the highest bounties. Wormhole here, if you are into money, maybe you can go look at that critical 5. And that's how we based our top 10, 3, whatever. So yeah, this is the current OWASP top 10 for 2021. Spoiler, it's not going to be the same for blockchain. And with that, I will leave it to Kennashka, who knows way more than I do. I am just an emotional support human.
Thank you, Amy. So now that we have talked about all the risk qualification and quantification and our prioritization aligned with the OWASP top 10 principle, let's go into how we have prioritized these lists. We're going to go through the top 3 lists due to time constraint. So our first on our top 3 lists would be cryptographic failure. So cryptographic failure, what is cryptographic failure? So cryptographic failure is a risk exposure of sensitive data as a whole. So it exists in the cryptocurrency space when you create a wallet, essentially. So when you create a wallet, we have asymmetric encryption, which involves the public key and the private key encryption. So we have the address, and then we have the private, which is the seed phrase as a whole. Why did we choose cryptographic failure? There is currently a $10 million bounty, which it currently exists on Immunify, which Amy have discussed. And we have decided to name the top 3 cryptographic failure as a whole, which the first one in our prioritization is the KECAC 256 cryptographic failure, which is essentially a hashing algorithm for addressing memory within the storage, essentially. Next up on the list, we have prioritized multi-signature architecture failure that exists, which this vulnerability exists essentially when you go to sign a transaction as a whole, and the application has to go through multi-different layer of confirmation and approval to approve a particular transaction. And then next up we have on the list is expose unencrypted private key, which this means a company has unencrypted data at rest that exists within a particular database as a whole. And now that we have discussed the failures, let's talk about some solutions.
It's really bad out there, okay? I have more questions and calls to action than solutions. I'm not going to lie to you. So, for example, multi-sig failures, right? So what if somebody dies? Cool, we can use some Web 2.0 solutions, right? Like what CSPs have been doing for a fairly long time, redundancy and so on, in several regions. We can also look at interplanetary file system. For example, for redundancy, this decentralized means of storing data, right, that concurrently gets released so that you don't sacrifice availability for speed and decentralization. However, when we start looking at things like implementing IAM as a solution for, oh my goodness, for our unencrypted private keys, well, then it gets a little strange, right? Because DeFi, right, decentralization, how do we implement that? Like, how do we implement an IAM scheme that's going to be decentralized? I don't know. And so this is a charge for security engineers, if you will. In terms of lifecycle management, right, I think solutions that are centralized have done a pretty good job of taking security out of the hands of developers. That's nice. They want to breathe. But to decentralize that is also a challenge, I think. Rotation, generation, and so on. So just some thoughts. If anybody can think of anything, please help us.
So to add a little bit more on what Aimee have discussed for the cryptographic failure, let's say, for instance, a normal user would create their seed phrase. So how would you protect your seed phrase, essentially? Do we write it down on a paper and store it away in a safe? Or do we resort back to centralized aspect of things, such as AWS, as Aimee has mentioned, identity access management roles, where we can, transfer ownership in case of emergency or in case anything happens. In addition, key rotation as well. How do we ensure that, our key doesn't stay the same? We can rotate it in such a way where it's creation and destruction of the particular key to ensure certain aspect of security within a decentralized world. So let's move on to broken access control. We all know our browser extension for holding our cryptocurrencies, which are browser-based cryptocurrency wallet, such as the Phantom, MetaMask wallet, one of the popular ones. What if a user, essentially signs a transaction that is insecure? How would a user be able to essentially read the contract itself? Any ideas? So there are multiple different projects. There's another aspect of things where projects that pose as trusted brands, such as projects like Bored Ape, Invisible Friends, Meta. You see, an ad on any particular platform which is mimicking that trusted brand, and you go to donate or support your favorite brand without reading or signing the particular contract, which exists mostly in NFTs as well. So let's move on to broken access control as it relates to insecure function contract calls. So this also allows you to write arbitrary code against a particular contract using platforms such as Remix, where essentially a user can execute arbitrary code to allow bad actors to claim ownership of the particular digital asset itself. So let's go into some of the solutions.
All right. I'm going to be repeating myself a lot. So an interesting project that just came out, or is about to come out, I think, by someone in Checkmarks, incidentally, for verifying libraries, is probably the solution that we need in this space. It's basically an extension that amasses a bunch of data on the credibility of a project, and then gives it a nice little check mark, sort of like, I think, Web of Trust. But yeah, no such solution exists at this time that aggregates credible data on whether or not a project you are working on is valid. And basically, you're on your own. And that is as a consumer, that is as a security engineer, let's say. And that's not a great state of things. Auditing a smart contract before signing it, yeah, that's great. Like, how are we, how to like find automated solutions? Well, a problem in this space is that there might be like a SaaS or a DaaS product, right? But it doesn't exist across all chains and protocols. So, for example, we started developing something for the Stacks protocol because it didn't exist as SaaS tool. Still working on it, but we'll get it out there. And then in terms of wallet access and policy and implementation, yeah, that's something that you can do right now, say like individually, but how can we scale that? Like, how do you work it out for a large enterprise, for example? I don't know. More questions for you.
So now that we have discussed our last topic, broken access control solution, let's jump right into security misconfiguration. So DeFi application, they allow us to, again, borrow money, borrow loan against our cryptocurrency trade. There's insurance industry that exists within the space, P2P, peer-to-peer lending, and more. So security misconfiguration within a particular smart contract application can drastically affect the end user as a whole, which one topic that we have highlighted is a flash loan attack. So a flash loan attack exists when a borrower, they intended to put up money to borrow against their cryptocurrency, but they haven't provided the collateral. So what are some of the solutions for that?
It's still pretty grim. Right. So I actually think that one of the best things we can do for these types of attacks is some of the manual work, right? Just code review, right? As I said before, don't want to repeat myself, but yeah, auditing tools don't exist across every chain, don't exist across every protocol, so SOL. And I think that's pretty much it for me. Some things that we want to point out if you want to learn a little bit more about blockchain security, these resources, there's a misspelling there, but Securium is an excellent DeFi security conference, and it's not just about smart contracts. It goes on to blockchain and so on. If you're interested in learning with them, they have a boot camp that will show you about bug bounty hunting. And honestly, even the Immunify site is excellent because they'll tell you, okay, if you've never done any auditing, here are some tools. Here's a list of things that you should know, some basic terminology. Unfortunately, we are putting some things down that are closed source for tooling that we suggest that you look into. Anomaly detection, for example, we have Forta, but there aren't enough open source projects, and that really is important for moving forward. Everyone's ability to inform their security posture in smaller organizations. On the Web 2.0, that is also underlying Web 3.0 technologies side, Seraphic is a really interesting product that's looking at memory management at the JavaScript engine level to block malicious transactions by sort of scrambling what content gets posted. And then obviously the rec database, but we already talked about that. If you want to just start learning about smart contract security, I'm sure you've heard of Capture the Ether, Crypto Zombies, really fun game, and Ethernaut. Yeah, those are my picks. And then There's, yeah, I guess you can put your final notes, and I will put in mine. Just
Yes.
yeah.
So we do want to, let me go back here. So I do want to add that FORTA, which is the anomaly detection product, which is an open source solution, there are not very much innovation as far as tooling to ensure the security of blockchain as a whole. FORTA does not exist across all chains. Primarily, it exists within Ethereum networks. I do want to add Sephoric product, which is a browser-based protection tool. It exists also at the memory level as a whole.
Okay, so I just want to say that it's so important for folks to develop products, not just because of access to, say, like smaller organizations and their security posture to improving that, but also because women and people of color are going to be left behind. We have to learn how to be, to use these products, right? We have to learn to be international policy experts. We have to learn how to be suddenly security engineers or security architects. We also have to learn how to be fiduciaries. How, right? And I'm not saying that, blockchain is, its value proposition is exclusively within the finance world. There are other and novel use cases for identification. But can we just make it a little easier for some of us? I think that is, while I'm not bullish on any of these technologies, Kennashka clearly is. I think it's so important to put in the time to solve these very big problems that are coming, whether you want them or not, because there's a lot of cash coming in and a community backing it. Final thoughts?
Well, I would like to wrap up with our last quote of the day. Blockchain application security, it does lack specific security guidance and resources. The blockchain may be secure as a whole, but the applications that lives on the blockchain, it may not be.
Thank you so much. We open the floor up to questions. And I'm going to tell you in advance, if we don't know the answer, we'll definitely get back to you, and you can certainly write us on Twitter and such. We'll put up our handles again. Thank you so much.
I think we have a question over here.
And I'm probably just going to point to Kennashka.
Thank you for a very interesting talk. You talked about smart contracts and code review. Are there any tools in the industry to validate, or to at least to help people understand the smart contracts that they are signing on?
So this is the list that I was talking about earlier with Immunify. If you are interested in looking at that, it's immunify.com/learn. They're not the only bug bounty shop in town, but this is a really good resource. You have, as I said, you have SaaS tools, DAS tools, all of these like traditional tools, but they don't exist for every chain. Do I have a recommendation on smart contract auditing tools? No, but this is theirs.
Other questions?
Yeah, another question I think I see. Thanks.
Do you see anything on the metaverse coming up?
Can you get a little closer to the mic like I am? I basically have to eat it.
Yeah. So do you have any security concerns you want to highlight on the metaverse?
Oh, insecurities in the metaverse. Oh, that's totally Kennashka's world, not mine.
So, aligned with the OWASP top 10 principles, there are many different security vulnerabilities that may exist as a whole. I would love to, get back to you, reach out to me via Twitter or email, and I would be glad to give you extensive lists.
I feel that there's a lot of financial crime in that space, so I don't know if that's your, thing. Next, thanks.
So with the L2s that are coming out, what are you guys So with the L2 block,
layer
chains
two,
coming out,
right,
how are you
yeah.
guys feeling about that? Like, what are the security concerns that you're like identifying there?
Let me see if I heard your question correctly. You said with the layer 2 change over to in Ethereum, right? What was the second half of the question? Sorry, it's a little.
The layer 2 chains, like
Yes. Oh,
Polygon,
chains.
security concerns there with, I guess, sending that data back, all the other things that like come with that. So, like, sorry, I work in the space and I just kind of like think right now it's been a long
It's
weekend.
really hard for me too. I can't listen to 3,000 things. And yeah. But go ahead, try again. Yeah.
So with the layer 2s and how they write back, like Arbitrum, Polygon, where they're sending the data back from the layer 2 chain back to like check marking into Ethereum, do you guys see any like security things that you can think of, like you can identify or like looked into?
So some security concerns that I overall have, you're referring to layer 2 solutions such as possibly like Polygon network as a whole. So some security vulnerabilities I think exist are the EVM at the EVM layer, Ethereum virtual machine, where the network bridge gap as a whole when you're swapping to a different particular network. I feel that there's a lot of vulnerabilities exist within that particular layer.
Yeah.
Thank you.
A bit of less of a question, more of a comment, and especially about, you mentioned auditing as being an important part of making sure that blockchain applications can be more secure. I work for one of the largest auditing firms, especially in the Solana ecosystem, and my observation has been that there's just a severe shortage of talent in that space. It's by far probably one of the most profitable things you could do in security, just because the bug bounty is like 10 million. You don't get that, like, for hacking into, I don't know, a browser or something. So I definitely encourage people to look into it. We've had to turn down since the beginning of the year, like probably 50 requests from blockchain protocols that wanted to get an audit, and just we couldn't schedule it in because like there's not enough talent there that we could even hire. And yeah, I also would encourage anybody who's building blockchain protocols to come up with like sensible bug bounties, because if there's, like we've seen, $300 million and more at stake that can be lost in any single hack, then it kind of makes sense to have a bug bounty system in place where, especially loss of funds bugs, just it needs to make sense to stay on the good side rather than like using the exploits. So those are my thoughts.
Yeah, you know, that's a really curious comment, because I have a buddy that said, well, what's the point of me securing this and finding this bug when, like, yeah, they're going to pay me this much, but I could make so much more tenfold. Another comment that I got from a bug bounty hunter was, well, you know, I'm backed up for like a year. I have so much work. So that's true. Thanks so much for your comment. I'm definitely going to get back in touch with you. Yes. And if there are no further questions, I really appreciate you all coming down.
Yes, definitely. Thank you for coming.
All right, let's put our
Thank
hands
you.
together.